This lesson is about the unit circle and how we use the unit circle to see the repetitive nature of trigonometry and the trig functions. So our objective is I can use a unit circle to find trig values. A unit circle is a circle with radius 1. The radius of 1. So we'll put a 1 here on the radius, and so how we usually use it is in relation to the angles 45, 45, 90, or 30, 60, 90, those triangles that we've done ratios with before. So if you recall in the 30, 60, 90, if you know the side opposite the 30-degree angle, then the hypotenuse is double that side, and the side opposite the 60-degree angle is the square root of 3 times that side. Now if you know the 45, 45 degree triangle, it's isosceles, so if you know the side opposite the 45-degree angle, they call that x, the other side would also be x, the same length, and then the hypotenuse would be the square root of 2 times that value. So we're going to use those to come up with values, like for instance if we do sine and cosine. Let's do sine of 45 degrees. If you do sine of 45 degrees, you get the opposite over the hypotenuse, which is x, over square root of 2 times x. The x's reduce. You rationalize the denominator by multiplying by the square root of 2 over the square root of 2, and you get the square root of 2 over 2, because you simplify the square root of 4. When you do the cosine, notice you get the exact same thing with cosine. Cosine is going to also be the adjacent, which is 45. Here, this could be the adjacent to the 45 is x, over the hypotenuse, which is square root of 2 times x. And then when you rationalize that, simplify and rationalize, you get square root of 2 over 2 again. When you do tangent of 45, that's equal to opposite x over x, which is x over x, which is just a 1. Now we're going to use that information in our triangle here when we do 45-degree angles. For instance, if we were to draw this angle in standard position up here, so this is a 45-degree angle, and we were to talk about the triangle form by dropping the side down to the to that radius, this value would be 1, this value would be our x value, and this value would be our y in this case. Notice that if we've got that, these two sides are going to end up being, because this is similar to this ratio, it's going to have an x value of square root of 2 over 2 and a y value of square root of 2 over 2. It's going to end up being the sine and the cosine of those if we have start with the radius of equal to 1. Now we're going to see something very similar happen when we deal with, let's go ahead and get rid of our 45, 45, 90. Let's do our 60-degree angle. Okay, so if we start with our 60-degree angle here, let's go ahead and do sine of 60. That's going to be the opposite, which is square root of 3 over 3x over 2x. The x's get rid of each other, and you end up with the square root of 3 over 2. If you do the cosine, notice you get the adjacent side for 60 degrees. Adjacent side will be x over 2 x's. The x will reduce out, and you end up getting just 1/2. And then lastly, if you do the tangent of 60 degrees, you're going to get the square root of 3x over square root of 3x over x, which is just the square root of 3. Okay, so what that will look like is if we draw a 60-degree angle here and drop this down. Okay, this is 60 degrees. What we have is that if you put the opposite side over the hypotenuse being 1, okay, then the sine of it, this over 1, will just be square root of 3 over 2, that's the y value. For the opposite side, the adjacent side, which is the x, will end up being this side here, which is the cosine has to be 1/2 over 1, gives me the x value for that. So by creating a unit circle, what we have is we can create all of these values for sine, cosine of the 30, 60, and also 45-degree angles. So let's do it on a more expansive route. Let's do it in every quadrant. So let's talk about the first quadrant here. This quadrant here is, this angle is 30 degrees, and the radian value is pi over 6. Okay, and if we put the x and y value there, we're going to get that to be square root of 3 over 2 is the cosine, and 1/2 is the sine of 30 degrees. If we do the 45-degree angle here, and then this one would be, this angle would be pi over 4 in radians. Remember, these two were just square root of 2 over 2 and square root of 2 over 2 for that. And then if we do the 60-degree angle, so we've got 60 degrees, and then this would be pi over 3. If you recall, then the x value was 1/2. That's the cosine of the 60 degrees, and then the y, which is sine, is square root of 3 over 2. So a secret idea here, and this is really important, is that these ordered pairs come in the pairs of cosine being the x value and sine being the y value of these ordered pairs. Now we can do it with 0 degrees too and build our way through. We're going to start with these 30s, 60s, and 45s. So what I want you to recognize when you're trying to think of this unit circle and how things repeat, everything here with the 30 degrees repeats over here with the 30 degrees. This is 30 degrees short of the 180 degrees all the way over here. This would be 180 degrees. So this angle here would be 150 degrees because it's 30 degrees short of it. So this would be 150 degrees. And then this value here would be 5 pi over 6. What's nice about the x and y value, the sines and the cosines, if I go with the cosine, it's this value here only in a negative quadrant. Cosine's negative on the side, so it's negative square root of 3 over 2. And the y value is exactly the same, 1/2. And so we can repeat that down here with this one here. We can repeat it. This is 30 degrees past 180 degrees. So this is 210 degrees. So this would be 7 pi over 6 in radians. And the x and y value, it's going to be the exact same x value as this. It's even x, y in terms of x here, so negative square root of 3 over 2. And then the y value will just be a negative. X and y are both negative in this third quadrant. And then if I go to the corresponding value over here, this one's going to have a 30 degrees short of 360. That makes it 330 degrees. That will make this value in radians 11 pi over 6. And then we look at this, and this has the same x value as this one, positive square root of 3 over 2. And it has the same y value as this one, negative 1/2. So what you're getting is a repetition of these values in all the other quadrants if I start looking at what's positive and negative in the different quadrants, and then just seeing how they relate to each other. So what that turns out to do is it gives us a unit circle that looks like this. We have the 30, 45, and 60 degree angles in the first quadrant, their values, and then you see them repeated. Like if you look at these two, they're the exact same, only the x is negative here. These two are exactly the same as that, only now the y is negative. And then these two are exactly the same, only the y is negative on that one. So you should be able to see the repetition that happens throughout this circle using those values from the first quadrant to complete our unit circle, and therefore we can see the repetitive nature that all these values keep repeating, and then once we get back to 360 or 2 pi in radians, it will repeat all these values over again. So the unit circle helps us to see values that are based on the 30-degree angle, the 60-degree angle, and also the 45-degree angle based on our special right triangles, and then building the repetition into the circle to see how they repeat.